In today's video, we shall be looking at the basic introduction of limit and continuity. Limit is very vital because it is the basics of calculus. Usually we use a substitutional method to solve the limit of a function. Consider this example as the limit of x tends to 1 and x squared minus 1 divided by x minus 1. So how do we solve this? Basically, we used substitution, direct substitution. So if we assume x to be equal to 1, this implies that 1 square minus 1 divided by 1 minus 1, this is equal to 1 minus 1 divided by 1 minus 1, and I have this 0 to be 0. That means this is undefined. But if we choose to use a number close to 1, take for instance, let's assume x to be equal to 0.9. This implies that if x is 0.9, I have 0.9 squared minus 1 divided by 0.9 minus 1. This is equal to 0.9 squared will give me 0.81 minus 1 divided by 0.9 minus 1, and this is equal to 0.81 minus 1 will give me 0.19 minus 0.1. Then when we divide minus 0.1, 0.19 divided by 0.1 will give me 1.9. Assuming x is equal to 1.1, and this implies that 1.1 squared minus 1 divided by 1.1 minus 1, this will give me 1.1 squared will give me 1.21 minus 1 divided by 1.1 minus 1 will give me 1.1 minus 1, and I have this to be equal to 0.21 divided by 0.1, and this is equal to 2.1. So basically, looking at this, as x approaches 1, the limit tends to be 2. When we have x to be 0.1, then our limit is 1.9, and if we have it to be 1.1, then our limit will be 2.1. Therefore, we can say that as x approaches 1, then our limit is 2. There's another way to solve it, which is by factorization. The limit of x tends to 1, x squared minus 1 all over x minus 1 will be equal to the limit as x tends to 1. This is different of 2 squared, and I have x plus 1 and x minus 1 divided by x minus 1. The x minus 1 can cancel x minus 1, then we are left with the limit of x tends to 1, x plus 1. Now we can substitute directly. If you substitute x to be 1, then we have that 1 plus 1 will give me 2. And this is the limit. For the next example, what's the limit if x tends to 2 of 2 into x plus 3 plus 7. Then for this question, you just have to impute the value of x straight to the expression. And we have that the limit is equal to the limit x tends to 2. You can open the brackets out. Then I have 2 multiplied by x will give me 2x. 2 multiplied by plus 3, that should be 6 plus 7. Then as the limit of x approaches 2, and we have 2x. 6 plus 7 will give me 13. Then this is equal to 2 multiplied by 2 plus 13. 2 multiplied by 2 is 4 plus 13, that will be 17, and this is the limit. The next example, what is the limit if limit of x tends to 1 of 3x plus 1 and x plus 1. To solve this, you can choose to open the brackets, and you can as well substitute the value of x directly. Okay, substituting the value of x directly, we have that this will be equal to 3 multiplied by 1 plus 1 and 1 plus 1, and this is equal to 3 multiplied by 1 will give me 3 and 1 plus 1 is 2, so that means this is 3 plus 1 is 4, and we have 2. This is equal to 4 by 2 will give me 8, and this is the limit. For this example, what is the limit as x tends to 1 of x cubed minus 1 divided by x minus 1? To solve this, remember this expression here is difference of cube roots, and the difference of cube root, assuming you have x squared x cubed minus y cubed, this is equal to x minus y into x squared plus xy plus y squared. Assuming our x to be x and y to be 1, then we have that x cubed minus 1 is equal to x minus 1 into x squared plus x multiplied by 1 plus 1 squared, and this is equal to x minus 1 x squared plus x plus 1. Therefore, the limit of this, our limit now as x approaches 1, is x minus 1 into x squared plus x plus 1 divided by x minus 1. The x minus 1 will cancel x minus 1, and we have the limit as x tends to 1 into x squared plus x plus 1. So substituting our x in this equation, we have that this is 1 squared plus 1 plus 1 This will give me 3, and this is our answer. The next example, what's the limit as x tends to 3 of 1 divided by x minus 1 divided by 3 divided by x minus 3. To solve this, we have to simplify this. We can multiply both sides, both the numerator and denominator, by 3. And that is, multiply this by 3x and multiply this by 3x as well. Then you have that as the limit x tends to 3 is equal to 3x multiplied by 1 over x minus 3x multiplied by 1 over 3 rather, divided by 3x into x minus 3. Then as the limit of this x tends to 3, we have that this is x will cancel x, then we are left with 3 minus here 3 will cancel 3, and will be left with x. So I have x divided by 3x into x minus 3, and x minus 3 will cancel x minus 3. Then I have that the limit as x tends to 3, 1 over 3. So x, substituting x to be 3, then we have that this is equal to 1 multiplied by 3 1 divided by 3 multiplied by 3, and this is equal to 1 divided by 9. And here is the limit. Thank you for watching our video. Please subscribe to our YouTube channel. If you have any question, don't hesitate to email us at science-elearning-academy@gmail.com. science-elearning-academy@gmail.com. Thank you.